Reflection of sound waves. By the end of this lesson, you should be able to describe applications of reflection of sound waves, calculate distances using the reflection of sound waves. Do you know that it is possible to see the image of the boy's kidney? What instrument is used to see the image of the kidney? How do whales communicate with each other? When a sound strikes on a surface, it is reflected, obeying the law of reflection. State the law of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. Compare the wavelength, the frequency, and the speed of the sound wave before and after reflection. The wavelength, the frequency, and the speed of the sound wave remain the same before and after reflection. Do you know what a reflected sound wave is called? A reflected sound wave is called an echo. When you shout in front of a wall from a distance, you'll hear an echo a few seconds later. For example, the time between the source and its echo is 2 times 10 to the power of -1 seconds. So, the time between the source and the wall is 1 times 10 to the power of -1 seconds. The distance of the sound in air can be calculated by multiplying the speed of sound in air by time. Thus, the distance between the source and the wall is 33 meters. Do you know in what areas are echoes used in our lives? To find the depth of the sea, light cannot be used, as light does not penetrate very deep into water. Thus, ships use echoes to find the depth of the sea beneath them. High-frequency sound waves, also known as ultrasounds, are used instead of using sounds in the audible range. The system that uses echoes to detect depth is known as sonar. Why are ultrasonic waves used instead of sound waves in the audible range? Ultrasonic waves are used instead of sound waves in the audible range because they can be emitted as narrow beams and do not spread out as much as the audible sounds. Furthermore, water absorbs less energy from ultrasounds and stronger echoes are produced. Click on the Start button. If the echo is detected after 0.4 seconds and the speed of sound in water is 1,500 meters per second, calculate the depth of the seabed. The time between the pulse and its echo is 0.4 seconds. So the time between the source and the seabed is 0.2 seconds. The depth of a seabed can be calculated by multiplying the speed of sound in water by time. Thus, the depth of the seabed is 300 meters. Echoes can be used to create images. The images show how a sunken ship might look if all the water was removed, and the sonar image of the same scene. Sound waves can be used in a similar way to see things. After turning on a sound source, the pattern of reflected sound waves that are bounced back can be seen. In hospitals, ultrasounds are used to monitor the condition of a fetus in the womb. Ultrasonic waves are emitted by a probe. These waves are then reflected back to the probe from different surfaces within the womb. The image is then seen on the screen. Bats emit ultrasounds and then listen for echoes. Their brains process these returning signals so that they can navigate around objects as well as hunt for prey. The pulse of a premature infant may be very difficult to detect with a stethoscope, since the sound produced is extremely faint. A sensitive Doppler pulse probe can be used instead because it detects the movement of the blood through an artery. The ultrasonic echo from the moving blood can be mixed with the source frequency to produce a beat frequency. As the blood surges with the pumping action of the heart, the beat frequency signals changes in frequency and amplitude. Place the tuning fork in front of the cardboard tube so that the sound from the tuning fork strikes the wall. Listen to the sound from the other cardboard tube. Move it to a position where the loudest sound can be heard.